In this lesson, you will learn to factor the sum and difference of cubes. So you'll follow the rule for factoring. You'll take the cube root of each term and follow the pattern for the factored form. You will need to memorize these patterns for the sum and difference of cubes. To help you remember the signs, use SOAP. So you'll use the same sign as the original problem. So if it's a positive, you'll use positive in the first factor. Or if it's negative, you'll use negative in the first factor. Then you'll use the opposite sign of the original problem. So opposite for that first term of the second factor. And then the last term of the second factor is always positive. So same, opposite, always positive, using SOAP to help you remember the signs. So let's go ahead and take a look at the first example. We'll begin by taking the cube root of each term. We can do this because we recognize each term as a perfect cube with a plus sign. So this would be the sum of cubes that we will follow for our rule. The cube root of x cubed, if you remember back with simplifying radicals, the index number tells us to look for 3 of the like factors, so that gives us an x. So the cube root of x to the third is x. You could also use prime factors to find the cube root of x, or find the cube root of 8. Hopefully that's one you memorize and recognize it equals 2. So we will use these terms to set up our factored form, starting with x plus, because we use the same sign, so x plus 2, and then we will write our x squared, opposite sign, multiplying your terms together to x, and then always positive for the last term and square that term. Of course, 2 squared is 4, which we will now simplify. So x plus 2, x squared minus 2x plus 4 is the factored form. And we used SOAP, same, opposite, and always positive to help us remember our signs. Let's take a look at example 2. This one we should recognize 27c to the third and 64d to the third as both perfect cubes. So this one we will follow the difference of perfect cubes to factor. Again, starting by finding the cube root of each term. The cube root of 27c cubed is 3c. The cube root of 64d cubed is 4d. So those are our terms that we will use to set up our factored form. So starting first with 3c minus, because we're going to use our same sign, so 3c minus 4d. Then we will take 3c and square it, again following our rule from up above. Make sure you use parentheses around your 3c so you remember to square your 3 and the c. So opposite sign now. We'll multiply our 3c times 4d, and we'll come back, of course, and simplify these things. And then finally, our last term is always positive, and it is our 4d squared, again using parentheses, making sure that we're going to square both the 4 and the d. So let's simplify this. We have 3c minus 4d for our first factored parentheses. 3 squared gives us 9, and c squared is c squared. Of course, using those exponent properties, each of those factors, 3 and c, both get squared. plus, we're going to just multiply 3 times 4 gives us 12, and our CD term. And then finally, we have plus 4 gets squared, which is 16, and D gets squared as D squared to finish our factored form. Again, remembering we use SOAP, same, opposite, and always positive to set up our signs for the factors. Now let's look at number 3. Again, hopefully we can recognize that 8x to the 6th and 27y to the 9th are both perfect cubes. We know they're perfect cubes. Hopefully 8 and 27, you recognize those numbers. But the variables have exponents that are divisible by 3. So let's find the cube roots. So the cube root of 8 is 2. The cube root of x to the 6. If you need to go off to the side and write out those variables and group them, you would put 3 in each group. Hopefully you realize you get x squared for the cube root of x to the 6. We're also going to take the cube root, not square root, but the cube root of 27y to the 9th, and that gives us a 3y to the 3rd. Of course, the cube root of 27 is 3, and if we have these 9 y's, we could get 3 groups of 3, with our index number being a 3, we can get 3 groups of those. So that equals 3y to the 3rd. So we'll now use those terms to set up our factors. So 2x squared, same sign, 3y cubed, 2x squared, but all of that gets squared, so we'll come back and simplify. So that was our same sign. We're now ready for the opposite sign. We're going to multiply the terms 2x squared times 3y cubed. And then finally, always positive, taking our 3y cubed and squaring it. So let's clean this up and simplify these factored forms. We have 2x squared plus 3y cubed, just bringing that down. We can square the 2 and the x squared. So 2 squared is 4, and x squared squared, remember that's power to power, you'll multiply, making that x to the 4th. We have 2 times 3, which gives us 6, and x squared y cubed, you just leave x squared y cubed. We cannot do anything with those exponents because they're not like bases. Just write them. X squared y cubed still multiplied together. And then finally, 3 squared gives us 9, and y cubed squared, power to power, you'll multiply to gives us y to the 6. And like any of our sum and difference of cubes, we used SOAP for our signs. Same sign, opposite, and always positive. Well, for our last example, be very cautious that this is actually a difference of perfect squares and a difference of cubes. Noticing x to the 6th and 64y to the 6th, those are actually both perfect squares and perfect cubes. So we'll need to start with the difference of perfect squares first. So with the difference of perfect squares, you actually take the square root of x to the 6th and square root of 64y to the 6th. not the cube root. If you're doing perfect squares, you take the square root. So the square root of x to the 6 gives us x to the third. Square root of 64y to the 6 gives us 8y to the third. We put that in the factored form following the rule of difference of squares with a plus and a minus sign. We'll now notice our factors from the difference of squares. These are now perfect cubes, the sum and difference of cubes. So we have to factor both of those again. Let's first focus in on just the sum of cubes. Well, actually, because of our terms, we can just find, let's just do the cube root of x to the third, which gives us x. The cube root of 8y to the third gives us 2y. So when we focus in on our sum of perfect cubes, we'll set up the signs for that first, and then we'll do the same for the difference of cubes, being careful of our signs. But as far as our terms go, they are the same. All right, let's take a piece at a time. Let's just factor for the sum of cubes. So we start with our x plus, because it's the same. So x plus 2y. Now we take our x squared, opposite sign, multiplying together our terms, so that's going to become 2xy. We typically put our variables in alphabetical order, so we'll do 2xy. And then always positive for the last term. When I square 2, it gives me a 4. And when I square y, it gives me y squared. So this is the factors for the sum of cubes portion. We'll now factor the difference of cubes. So we have x, same sign, so x minus 2y. We have x squared, opposite sign, multiply together your terms, 2 times x times y, and then finally always positive, and we square the last term, so 4y squared. So those two parentheses are the factors. Those are the factors of the difference of cubes for this. Don't let this problem overwhelm you, but recognizing first that it is the difference of squares and it is factorable, and then those are the sum and difference of squares, and each of those are factorable. This is the complete factored form for this problem. Something to recognize in order to be prepared for this lesson is knowing your perfect cubes. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, 7 cubed is 343, 8 cubed is 512, 9 cubed is 729, and 10 cubed is 1000. So it's helpful to know your perfect cubes so you can recognize those sum and difference of cubes.